My name is Zoe Laycock. I'm responsible for product and developer marketing here at DivBlue. And DivBlue exists to lead the charge in using autonomous AI to augment developers and to automate away the pain of manual, mundane coding tasks. And so I'm going to pass over now to Matthew Lodge, who is our Chief Bottle Washer, lead DivBlue cover evangelist, and in his spare time is CEO of DivBlue. And I'd just also like to say that we have Animesh Mishra on the line, who is our senior solutions engineer, who will be on hand to answer any questions at the end of the session. So without further ado, revolutionizing Java unit test generation and streamlining test operations with the help of autonomous AI powered by reinforcement learning. Matthew's going to take you through.
Great. Thanks, Zoe. Welcome, everyone. So DivBlue is a generative AI for code company. We are here in Oxford in the UK. You can see some of our customers on this slide. And I'm going to talk a little bit about what we do. These are the customers who benefit from what we do at DivBlue. We're also a Gartner cool vendor for DevOps. So what I'm going to do is take you through what does DivBlue do and how do we do it. And the spoiler there is that unlike seemingly everything else these days, we don't use a large language model. And so I'll explain that. And then we've got a live demonstration. I'm going to run the demo here on my own machine. We're going to look at DivBlue cover integrated into CI, and we're going to look at the inner loop, so inside of your IDE, how you can use cover to write unit tests for you. And then we're going to a quick look at the dashboards so you can understand what cover is doing, what kind of coverage you get, where the risks are in your project. And then we'll close out with some customer stories and talk about some of the business impact of what we do. So DivBlue writes unit tests for Java and Kotlin code. So if you think about the overall testing process, unit tests are run by developers at the time they are writing the code. One of the key things that unit tests do for you is help you find regressions in your code base so that you can fix bugs as you go. So regressions being unintended changes in behavior. So everything we do at DivBlue is about writing that kind of code. We don't do anything to do with the right-hand side of this diagram, which is sort of more traditional QA testing. So things like functional testing, end-to-end testing, and integration tests. So we just write the code for unit tests. At a high level, the way the product works is that DivBlue can write unit tests for an entire application. The big difference between DivBlue and some of the other projects you might have looked at in the automated coding space is they were not a code suggestion tool. So the tests that are written by DivBlue compile and run and find bugs. And so they're fully accurate and they're written autonomously as a result. So you can point DivBlue at a million-line Java project, get tens of thousands of unit tests in a single run. So once you've got that test baseline, essentially you've got a set of unit tests that reflect the current behavior of your code, of your application, so that when developers make changes to the application, they can run those unit tests to help them find regressions. So failing tests can indicate regressions. Developer takes a look at the test failures and determines what to do about that. And eventually, at some point, you've got something like a merge request or a pull request that gets approved, and it's merged back into your mainline code base. So at that point, you now have to update your unit test baseline because the behavior of your code has changed, and we automate that process as well. So we solve your day one problem by giving you unit tests and high coverage that matches your existing application. And then we solve your day two problem, which is maintaining that level of test coverage. And in some cases, being able to increase it as time goes on, right? So the test maintenance challenge. So here's what that looks like in terms of a software lifecycle. You see you've got your code base, you write your unit test baseline. So now you've got your code plus the DivBlue unit test together. When developers work on the code inside of an IDE, then they can use DivBlue integrated into the IDE to update the tests as they go, create that pull merge request. And you can also, at this point, have DivBlue run again inside of CI in what's called incremental mode. And I will show you that later on. The objective there is that the developer may have missed something in their IDE when they were creating their own tests. There may be ripple effects. If you change the code associated with an object that is then used elsewhere, it's part of other objects or it's inherited, then you're changing the behavior of all of those other objects as well. And so you may need to rewrite other unit tests. And so Diffblue can do that for you and can add those changes to a PR so that the whole thing can be reviewed, right? You've got your new test for the code you've written, any other tests that needed to change, and the whole thing can be reviewed and then merged. So I'm going to give you a live demonstration. So what I'm going to do is we're going to switch over to the terminal, and I'm going to do this here. So here is my terminal. I'm going to be using Spring Pet Clinic application. And so I'm going to modify the Java code for that. So you can see I'm sitting in the base directory of Spring Pet Clinic. And if I run git status, you can see that I'm on a branch called Diffblue tests. I'm going to create some tests. But you may not be familiar with Pet Clinic. So I'm going to give you a quick demonstration just in case you haven't seen that before, and you can understand what this application does. So if I switch over into Chrome here, this is Spring Pet Clinic. So for Spring Java, it's an example application. It's a classic database-driven application. You've got a front end, you've got the Spring Java, the application itself. So think of it as the back end. And then you've got a database behind that. So a classic architecture for a web application. And so in Spring Pet Clinic, you can do things like look for owners. And so there's some example data that ships with the application. So if I don't put in a last name for the when I'm trying to find an owner, I get the full list. I get a nice paginated list you can see here. That's all coming from searching the database on the back end, looking for a match. If I put in Davis as the last name, I get the list of all the owners that match Davis. If I put in McTavish, it's on that list that we saw, there's only one owner with the name McTavish, and we have a nice little optimization here. We get sent straight to the page for McTavish, right? So you don't get a list with one item in it. You go straight to the page for that, so it's a nice little optimization. If I put my own name in here, it won't found it, and you get a little error message, and we will stay on this page. So that's Pet Clinic. And so what I'm going to do is just kick off the writing of the tests. So if I can find the right window. There we go. Oops. No, that's the wrong window. Let me try that again. Dear, oh dear. There we go. That's the right terminal window. All right, so I'm in the base directory of this particular project. I've got my Java code here, and so I can just run dcover create, and we will start to write tests. And so dcover create is running locally. So I'm running this on an Apple MacBook Pro. It's got Apple Silicon in it. This is an M1 version of the MacBook Pro from a couple of years ago. And you can see that we have started this process of writing unit tests. It'll take about 2.5–3.5 minutes, depending on the system, to write all those unit tests for the entire application. And so we're going to come back to this a little bit later on. So we're going to let it run, and you can see it started to write tests. In the meantime, what I'm going to do is switch back to slides and just explain to you what is going on. So while it's writing those tests in the background there, I'm going to talk a little bit about how Diffblue works. So Diffblue uses reinforcement learning. So reinforcement learning is better known in machine learning industry for game playing. So things like Google AlphaGo use reinforcement learning. And about a decade ago, there was a lot of work around reinforcement learning for lots of different games. And essentially what happens in reinforcement learning is that you search for the answer. In the case of AlphaGo, you're searching for the best Go move that you can make. We do something similar where we search for the best unit tests. So I'll explain how that works. So if we look at AlphaGo, The reason you need a search strategy at all is because of the size of the potential move space. It's bigger than the number of atoms in the known universe. So you can't look at all of the different alternative moves and just figure out which the best one is. That is a strategy that you can do for games like chess because the move space is a lot smaller. And so if you look at the leading product for an open source project called Stockfish that plays chess automatically, there is no AI in Stockfish. It just looks at all the possible moves and picks the best one. And that was the approach that IBM took with Deep Blue as well. So you have to conduct an effective search. You have to ignore a large part of the space. So how do you do that? Well, that's what you do with reinforcement learning. You conduct a probabilistic search. So probabilistic means that you identify areas of the solution space, the move space in the case of Go, where solutions are most likely to be found. So the way that that happens in AlphaGo is that they use a neural network to make a prediction about where those places are. And then the search is guided by reinforcement learning. So in the case of AlphaGo, they generate potential moves and evaluate the effectiveness of each of those moves. Again, they use a neural network for that process. So they make a win prediction, essentially, using that neural network. And that helps guide the search. Like, has the chance of winning improved? Is it going in the wrong direction? And that guides the search. So that's how reinforcement learning moves for AlphaGo. If you've ever seen a reinforcement learning diagram before, they all look the same. They all have 3 boxes on them. And essentially what we do in AlphaGo is that you make a prediction about a move, what's a good move. You try the move out on the board, evaluate the move space, make that win prediction, understand what the move strength is from that. And from that, you can then iterate and predict what a better move might be. And so in AlphaGo, you go through this loop until you found the best move that you can. The moves in AlphaGo are actually randomly generated, but the search is guided by this reinforcement learning loop. So with test writing, it's a very similar problem. So the search space is also exponential. So it's like Go in the sense that if you think about all of the possible unit tests that you could write for a particular method in a program, there are just way too many of those to try them all, right? There are just too many. And so we want to approach it like a game, very similar to what we do with AlphaGo, where winning is to have tests with 100% coverage that find bugs, right? That's what you're essentially optimizing for. So you've got this notion of you have an optimal result, which is 100% coverage. So in terms of the analysis that we do, so in order to figure out where are likely solutions to be found, we analyze the program. So we use our analysis of the program to make a prediction about what a good test might look like. And then we run that test, we generate potential tests, and we run them to evaluate their effectiveness. So essentially what you see here is that we start out with a prediction for a test. We write that test in the sense of we generate bytecode, we run it against the method under test, and then we see what happens. What kind of coverage did it get? Did it throw an exception? Those kinds of things. So we take all of that information, feed it back into prediction, and then we can predict what a better test might be. We write that test, we run it, we see how it performs, and so on. And so by iterating through this process, at the end of this, for each method, we end up with the best unit test that we can find. So I'm not guaranteed to find them all, but this does work incredibly well. And it's kind of similar to AlphaGo, and it doesn't guarantee to play the best Go move, but it just needs to beat its opponent. In our case, we need to get high coverage. We don't need to get 100% coverage. We need to get high coverage, and it's the same kind of thing here. So that's essentially what is going on. So the reason that works so well on my own computer is because that can be incredibly efficient, and we'll look at that in a second. But to give you some idea of what the business benefit of this is a Goldman Sachs case study you can download from our website. So at Goldman Sachs, we wrote 3,100 tests in about 8 hours. And then we asked Goldman, how long would it take to write those if a developer wrote those? And so, the sort of back of the envelope, let's say it takes 10 minutes per test to write a unit test. Some will be faster, some will be slower. And you do the calculation, 6 hours a day of productive time. And then you look at how many days a year you might work, and you take out holidays and all those things. And you come up with that figure. So, right, so this is not exact science, but it gives you a rough idea. And basically, it's a year of developers' time to write 3,100 tests, and we're able to double their coverage effectively. So you can see that this has a very high business benefit, and that's solving your day one problem. So let's move on to the next part of the demonstration. We're going to go back to our terminal window because it's finished now, and we're going to take a look at the test that we got here. And then we're going to take a look at what happens with the developer in the inner loop when we can start editing those tests and adding new things and seeing what it does to our unit tests inside of IntelliJ. So I'll do my trick again and switch to the desktop. So what I can see here is that it finished in 2 minutes, 59 seconds. We had 100 methods. We created 100 methods in total. We created 98 tests, so almost 100 tests in 2 minutes, 30 seconds, so about 3 seconds per test. We aren't testing all the methods because some of those methods are things like trivial constructors, right? We don't write a unit test for every single constructor because they tend to be kind of trivial. And so the way that we test constructors is when we're writing other unit tests that create objects that we then use in the unit test, the constructors get tested that way. So that's why you don't see 198 tests for 100 methods. And there's a couple of things here. We've found a couple of situations where there are missing observers on some of these objects, so we couldn't write an assertion. And so one of the things we've done here is created a refactoring recipe. So we've got some refactoring that we can do for you. You could run dcover refactor at this point, add those missing observers to those objects, and you'll be able to get more unit tests. I'm not going to do that, but you can see what that looks like. And so I can see that in Git status, I've created all of these additional objects. What I'm going to do is create a new branch. I'm going to switch to that branch. Right, so now I can add all of those tests to it. And so at this point, I've got everything added. There are all those unit tests. There's the full list. And so I can commit those. These are our baseline tests. Right, so there we go. And then I can then push that. If I can type correctly, I can then push that. Oh, has no upstream branch. But Git is kind enough to tell me exactly what I need to do in order to push that up there. So I've then pushed this up to GitHub. And so now if I go into GitHub, what I can do if I just refresh this. And there we go. Diffblue test, we've got a new branch. We can create a pull request for that. And here's my pull request with all of my changes in here. And you can see there's the full list of all the tests. So I've got a complete set of unit tests that are generated completely automatically. On my branch here, I can review this PR. And when I'm happy with it, I can commit this into my baseline. And at that point, I've got a full set of tests for this application. So we can see that this is fairly straightforward stuff when it comes to creating that test baseline. And I could put this into CI. So I ran this locally on my laptop, but there's no reason why that couldn't run inside of a CI runner. And so this would be something like a GitHub action that you could run that would give you this test baseline for your project. And you might want to do this maybe at the beginning, obviously, but also perhaps after every release, and things like that. So I've got my test baseline. What I'm going to now is switch over into IntelliJ. So I've got, again, my demonstration projects here. Here are all those new tests that I just wrote, sitting in IntelliJ. And so what I'm going to do is go look at some of these tests in more detail. So I just said, look, here are some tests that we wrote, but we didn't spend any time sort of looking at those in any depth. And so what we're going to do now is go through these, and I'm going to go through that logic that I just showed you right back at the beginning, where we did search for owners. And the code for that is in the owner controller. And so if I go into ownercontroller.java and scroll down a little while, what I get to is this method called process_find_form. And so we can see all the logic that we explored back there, where if the last name is null, we search for everything. If we get, we don't find anything, we go back to the find owners homepage. If we get exactly one result, we go straight to the result for that one. Otherwise, we return this paginated list. So there's our code. And so let's look at the test that we wrote. So what do we write as Diffblue? So first of all, we've got some mocking here. So, unit tests, you want to mock out the database, you want to mock out the web server, so these tests run quickly, and that's what we're doing initially here in this first test. So you can see there's a when-then statement where we're just going to return an empty list of owners. We're going to pass in the null value. We're going to hit that first branch that we saw there. This is a fairly boring test because it just basically checks to see if we got to the right place, even though we didn't return any owners, which satisfies the if statement, but is not a very interesting test result. Slightly more interesting is the next one we've constructed for the single owner case. So we've got our when-then statement here. So we've constructed this object up here with some synthetic data for the owner. So we've created an owner, put it into an array, we've added it as an owner and wrapped it in the pagination object, the right method here. And we return that object now. So we, instead of having a database call, we've got exactly one object that we've created. And the next thing we want to do is run that. So we mock the call into the controller, and then we check to see that that succeeded and that we got redirected back to the page for owner number one, right? So we set the ID up here to number one. And so we need to make sure this matches down here. The next test, as you might imagine, has got two owners. So we can trigger that final case. Sorry, it's not the final case, the third case where we've got more than one result. And so we've generated, again, some synthetic data. The synthetic data you're seeing here comes out of a dictionary. So we ship a dictionary with the product. You can extend that dictionary. You can add your own data. If you have particular data patterns or things that you want to see, you can add that yourself. So that's where that comes from. And same kind of thing, we return the two owners in the object. And then here, now we're checking the result to see, we make sure it has the right attributes. It's a paginated list. That's important. And that we get redirected back to the right page. So then we've got three lists for the main logic. And then the fourth test, and the reason why that one wasn't final, is the case where it's not found. And so what we're doing here, over here on the side, is searching for DOE when the array list is empty. So that will guarantee that it will fail. Same kind of thing. We just make sure that is correct and we get redirected back to the right place. In this case, back to the find owners page. So there's an example of what the tests look like. Now, what happens if I change the code? So I'm going to go back to owner controller. And what I'm going to do here is add some code to this process find form. So we're going to see what happens when we make a change and we want to update our tests. So the way I'm going to do that is I'm going to go to Vim here because I'm old enough and I learned Vim. That was the first editor that I learned. And so I'm going to cut and paste a little code change here that I'm going to drop in right here. And so I'm going to add in a new condition. I'm going to add in a bounds check. It basically says if this pagination result is negative, then I'm going to throw an error, basically, and go back to the find owners page. So, so I've got some new code, And so the next thing that I want to do is update the test for process find form. And so with Diffblue integrated in IntelliJ, I have this Flask icon. And so what I can do is just click on this Flask icon and it will rewrite the tests for that method. And so inside of IntelliJ, it's very similar to what happens with the command line version I showed you earlier on. First thing we do is we check the environment. That actually went very quickly, so let's just spend a second or two looking at this. So Diffblue, because it's software that runs inside your Java environment, it can interrogate the Java environment. So it knows what build system you have. It knows what your mocking framework is. And so by interrogating the system, we can guarantee to write correct code. We know which version of Java you're using. We know which version of JUnit. And it's the same thing. So we see that you're using JUnit as project, so we write tests in JUnit. If you were using testng, we would write tests with testng. So that's the advantage here. And this went very quickly. And so we got our tests already. And we can see that 3 of them are the same. We've got an additional test now. And so find form 4. And we've got a value where we pass in -1, right? So we essentially did that search, right? And we saw that we saw that this page value became significant. And so we went looking to see what we could find with that particular page value. And that's how we ended up with this particular test. And so what that means is this 4th test now has the page -1, and the 5th test is now the one where it is a search for dough and it's not found, right? So the not found test moved to test 5 and test 4 changed. So as a developer, I was able to very quickly get new unit tests that match the way my code operates. The other advantage of looking at the test like this is it tells you what your code actually does, which might sound odd, but sometimes we don't realize what the behavior of our code is. And the unit tests are essentially a way of documenting the behavior of the code. So you could think about it that way as well. So that's the example with IntelliJ, and I could then take this and I could put it into my pull request and do everything else here. The other way that you can do this is to do this automatically in CI. And so you might ask the question, like, why would you want to do that, right? That's a terrible. I've got lots of diffs here. You might want to do that in CI. So why is that? Well, what happens with developers is that typically when you're in the inner loop, you're running the unit test for the piece of code that you're working on, right? So you want to make sure the test pass for the changes that you're making. So the areas of the code that you're doing, and what you want to do in that situation is work quickly, right? So you're iterating and through the code, and you're making changes, and you're going back and forth. And what can happen though with the unit tests is that a change in one particular area can ripple through the rest of the unit tests into modules that are outside the ones the developer is working on. And so you can run and decover in CI, and you can pass it in the patch file, so the diff for this particular example. So we made that small change to that file. We could pass the diff in there, and then Diffblue cover will look and see which unit tests are impacted by that change, and rewrite just the unit tests that need to be changed for that, which is very important on big projects where you might have tens of thousands of unit tests. You want to have to rewrite them all every single time. And so the big advantage from what we do there is that we can figure out, okay, so maybe no unit test needs to change, or maybe it's 10 or 100, whatever. If you change something that's a core object that's used in lots of other places, you'll end up with lots and lots of changes if you make any changes to that core object. And I was going to show that to you, but I've messed up my my Git, and that's why that didn't work. So full disclosure there, but you can automate that process. And what I'm going to do is switch back into PowerPoint. So if I go to Chrome, and here is my dashboard for Pet Clinic. And so this is essentially telling me what kind of coverage I'm getting from my project, I can see that my coverage over time. I can see that my DivBlue coverage here for Pet Clinic is 83.27%. I can see what my total coverage is. There are some manual tests that were written by humans along here. And we can see how many tests we are. This is a partial run. We've got fewer tests here at 77. I can look at the coverage map. And so what I can see here is that on Spring Pet Clinic, then I've got some, the application itself, which is 3 lines of code. That's the main method that I was talking about before. And I might go into here and I might sort of see, okay, so what's going on? Where am I not seeing coverage? And I can drill down and take a look at that. And I can get into the coverage detail. I can understand how many tests I have. And then I've got what my advisories are. So those are those trivial constructors I was telling you about. This is where it's a frame configuration callback. So we can see why we didn't get a test for that. So the whole idea of this dashboard is that you can understand exactly what's going on with your particular project. You can go and look at a different run of this. You can see what the changes over time, and you get to understand where you stand with your unit tests, what kind of coverage you have, and what kind of issues you might have. So switching back to slides. Having completed the demo, even though I messed it up there right at the end, let's just talk about some customers. So Goldman Sachs, I mentioned earlier on. So in that particular example was monolithic application, been around for a long time, important to Goldman Sachs, and they needed to do substantial refactoring. It is very hard to do refactoring on something like that if you don't have good unit tests. So that's the main value there. So that enabled them to go a lot faster, right? To get on with that refactoring. Cisco is an interesting example. So Cisco uses DivBlue Cover for its IoT application. So they have an application that manages over 200 million different IoT devices, and it manages the connectivity to those devices. So the mobile service, all of the SIM cards, billing, all of those things for hundreds of millions of IoT endpoints. So this is things like Teslas and Fords. It's also things like industrial equipment and controls, all of those things out there in IoT land. And so essentially what they're doing with that application is they're breaking it down into smaller chunks and moving towards more of a microservices architecture. They're refactoring the data layer, they're making it more reliable. And essentially why DivBlue enables them to get all of the unit tests that they need for that project, so they can do that with confidence, and they can reduce their risk. They can reduce the number of defects that make it into the final product. And so, incredible value from having much better unit tests. Another example on here is Raytheon, where you're modernizing a business critical government application in this case. So again, modernization, moving to the cloud, that's what they're really looking to do. Very difficult to do that, again, if you don't have unit tests. And so within the first couple of weeks, they managed to get unit tests for the first 500K lines of code. We ended up ultimately helping them write unit tests for over 1 million lines of code. So you're looking at 50,000 unit tests for an application like that. So that gives you some idea of how it's useful for application modernization. So to wrap up, it is AI, but not as you know it. It's a fully autonomous, as you've seen in the demonstration. So it is not a suggestion tool. It is not an assistant. It is something that you work alongside of you, but it writes accurate, correct code. It's not a trained AI model, so you don't have a lot of the issues that go along with trained models in terms of where does the training data come from? Does it try and train on your code? You don't have to fine tune it to support your own code. It's because of the way it works, it already knows how to write unit tests for your code, and it knows about your libraries because it sees them. Obviously, it doesn't hallucinate because it's not a large language model. And it runs 100% inside your development environment. You saw me run that on my own machine. It's running locally, and you can see how you could run that on in a CI runner or something like that. So it is something that runs inside your development environment. It's also the reason that all of that environment checking works essentially because DiffBlue cover runs inside your Java environment. It can configure itself, and it understands all the different Java versions and so on. And then finally, we don't use your code for training. So what the big benefit is that you get unit tests at scale that are accurate and you get them quickly. And that's incredibly powerful stuff, right? You can get really good coverage because we're running an optimization algorithm, essentially. That's what reinforcement learning is. It is goal seeking to try and optimize a metric, and in this case, it's coverage. Right? And so the advantage of that is it means you can ship software faster, your developers can be more productive, and you can increase their code quality and consistency. So I'm going to stop there. I'm going to hand it back to Zoe. And I believe that we are going to do Q&A. Is that right?
That is absolutely right. And we have a couple of questions waiting. So we'll dive straight in. So we have a question from Rananath. When do you think you will start support for Java 17 and test containers? I think we've got some good news on the first part of that.
Yeah, so we already have support for Java 17 and we have support for Java 21 as well. It's already in the product. I don't know the answer to the test containers question, though. Animesh?
Test containers are, it's a technology that allows you to quickly spin up in-memory databases, message brokers, etc., that your code relies on. If I could put my cheeky developer hat on, it's a solution to developers not wanting to write mocks. And it can be quite painful to write mocks for these things. Because DiffBlue is not will write mocks and the whole test for you. Test containers are something that we don't need to worry about.
Thank you.
Thank you. Thanks for that answer. Hopefully that satisfies the question. If you have any follow-up questions, please ask. In the meantime, we'll move on to the next one. So Path, can we use DiffBlue? This is an ID question. Can we use DiffBlue in Spring Tool Suite, SCS, or Eclipse as well as IntelliJ?
So we do have instructions on how to use DiffBlue cover in Eclipse. It's in the documentation. So it's in docs.diffblue.com. And I don't know the answer to the other question. Animesh, do you know?
I'm afraid not. But at the end of the day, the command line interface runs locally. So if you can ARM twist your IDE into running something locally, you can get your IDE to run cover.
There's always a hack around that. I mean, naturally, we prioritize developer experience. And the other thing I would say is jump into our forum. We try and prioritize things by need. So maybe you want to start up a campaign for us to support Eclipse. But certainly most developers are on IntelliJ, and we're always looking to roll out our support across different IDs and other parts of your stack. So we will move on. Okay, so Abhilash has two questions. We'll start with the first one. Which Java version onwards DiffBlue can be applied? I think that's possibly similar to the first one.
Yeah, Java 8.
Yeah.
It's the oldest version of Java we support.
Okay, and then moving on, security concerns. This is a big one for most people with all aspects of AI for code, AI for developer tools. And the question is security concerns for the code exposure. How does this affect existing test codes written manually?
So we won't overwrite, we'll never overwrite tests that you've written yourself. So the tests that DiffBlue creates are always in addition to any test that you've written yourself.
Okay, all right. So Marco, we have a question from Marco. What if there was a bug in the code you wrote in your demo? Would the test fail?
So no, well, so our product only knows what your code does. We don't know what you intended it to do because that's usually in your head somewhere and is rarely written down. And the main purpose of unit tests is to find regressions, which, unit tests by definition will pass, right? If you've got a project with unit tests in it, in the main line, you run the test, they will all pass. So they're not there to find both you made a mistake in transcribing between what you had in your head and what you put into the code, and you might introduce an error that way, or a design error or something like that. Unit tests are there to find regressions. That's the purpose of unit tests, so that the next time you change your code. So we won't find those. I think the other important thing is that by the time you've shipped your code with all those bugs in it, every other system that touches your code depends on that behavior, whether it's right or not. So it is important that your unit tests reflect the current behavior, because if you change that, you fix that bug, you may end up impacting some other system. So it's important that you know about that, and unit tests would tell you.
Thank you, Matthew. And I'm not sure, I think I just skipped over. So just so we come back to the point, security concerns.
Yeah.
So this was from Abhilash, and he's basically just asking about security concerns for the code exposure. So we did just touch on this, but perhaps you can reinforce one of the penultimate slides that you just presented about how Diffblue works as an on-prem solution.
Okay, I see. So if the question is, what happens to my code? Does Diffblue ever see it? If that's the question, then the answer is no, we don't see it. It runs entirely locally. We have a couple of cloud services that we use for licensing and for telemetry, which are basically used to support the product and help us figure out what you're doing so we can improve it. And that's it. We never see your code. It never gets sent to Diffblue, never leaves your machine.
Okay, hopefully that answers the question. If you have more, please put them in the Q&A. And then Farhad, he has a question again about stability and reliability of the tests generated. So the question is there any concern in terms of the stability and reliability of the tests generated? For example, when there's non-determinism in the production code?
Yes. Yeah, that's a great question. Yes. So given that we rely on the behavior that we observe when we write the test, right? So one of the ways that we write assertions is we run the code and we know what changes it makes to the state of the program. And that's how we can write assertions that are correct. And so if you have non-deterministic or other random behavior in your program, then that will be wrong. And that's one of the reasons that we run test validation. So I showed you back at the beginning, right at the end of the process, we ran all those tests again using the build system. And that's one of the reasons why we do that. So if there is non-determinism, then that test is going to fail. And the default behavior that we have in that situation is to delete that test because it should pass. And if it's not passing, then it means there's a problem. And so we delete it. And we do it that way so you can run Diffblue cover inside of your continuous integration pipeline, because you do not need and you do not want failing unit tests in your pipeline. So that's how we handle, that's how we spot things like determinism, non-deterministic code. And then we also have special handling for code that deals with dates and times. And as a special case, because you can get the same kind of thing happening if you're running unit tests at a particular date and time or time zone. We have seen that as well. And so we have special handling for that so that we write unit tests that do not fail when you're in a different time zone or run it on a different day.